So for this one here, to find x, what we need to find is we need to find this overall height all the way up to the top. And subtract the 2.6 inches here, and that'll give us x. So to find that overall height, we have to build it in pieces. We have one piece right here, the 0.8 inches, that goes up to here. Then if we go from there to the center of our round stock, that'll be the second dimension. Then finally, we've got the radius of the round stock here would be our final dimension. Well, that radius is 1.1 inches, half of our diameter that's given here. So all we're left to find is this piece here. Oops, color's going through. There we go. So to find that red dimension there, we know to create right triangles, we either have to look for horizontal and vertical dimensions that intersect. That's not the case here. Or we look for a radius of a circle to a tangent, and that's what this one is. The radius here is going to be perpendicular, right angle to that tangent. We know that that whole angle here was 7240. When we connect the center to that intersecting tangents down there, it cuts that angle in half, so that angle is going to be 3620. So what we have is, I'm going to just draw that triangle a little bit bigger here. This is 36 degrees, 20 minutes. This is 1.1 inches. This is a right angle, and what we're looking for here, what side is this that we're looking for here in blue? This is the hypotenuse. And according to the 3620 angle, the 1.1 would be the opposite or adjacent? Opposite. So opposite and hypotenuse make what trig function? Sine. So we read out our definition, sine of theta, opposite over hypotenuse. We fill in what we know, the angle, 36 degrees, 20 minutes. Opposite side is 1.1, and we are looking for our hypotenuse. So since we're looking for a side, remember when we're looking for a missing side, we make it into a proportion and we cross, multiply, and divide. So here to solve this, it's going to be 1 times 1.1, which of course is just 1.1, divided by the sine of 3620. Divided by sine 36. Now I have to go into my angle menu. Your angle menus are different for each of your calculators. 36 degrees, 20 minutes. And that gives me that the hypotenuse is 1.857 if we round that to 3 decimal places. So this dimension is 1.857, which is, in this drawing up here, this dimension right here. So that overall height here is the 1.1 plus the 1.857 plus the 0.8 so 3.757, and we'll subtract our 2.6. 1.157 inches is our x. Any questions? You got questions? Okay. Well, we're going to do some examples off of the homework. We're looking in your packet. This is actually going to be off of page 368 in your packet. I'm going to do just a couple of examples, and then I'm going to turn you guys loose working on this, because really the only way to get good at these is to do them. Yeah, we'll get to some of those eventually. So I want to look at number 4 on page 368. This one takes a little bit different look at these types of problems. We have a V cut in a block here, but the bottom of the V is rounded. It is telling us that that is a 43.80 millimeter radius from one side to center is 101 millimeters. Total width is 202 millimeters. From bottom to center of that circle is 97.5 millimeters. Total height of the block is 143.3 millimeters. And then we're given 38 millimeters on each side here. What we are being asked to find for this one is that angle right there, angle Y. Well, to find that angle, what I would do is this, is I would cut out this triangle right here. That's a right triangle. I cut, this is a vertical side here, horizontal piece here, so I know they make a right angle. So I'm creating that right triangle using horizontal and vertical dimensions. So I need to find those dimensions. To find those dimensions, the triangle I'm going to be working with here, now that triangle I created there goes to the point of tangency where that radius is tangent to that, or intersects that tangent. So that's a right angle there as well. And I'm just throwing out right triangles right now to see which ones I can find, which sides I can find and which ones I can't find. Because if I can find, if this is also a right triangle because there's a vertical and horizontal dimension, if I can find any one of these angles, this one, or this one, then I can find angle Y. It's related to it. So looking at this, let's see what I can do. Okay, well, let's just label some dimensions as we can find them here. From here to center is going to be how much? Well, 101 minus the 38 is going to be 63. I'm not going to put the decimal points after it. We know it's 63.00. Not quite, because that's not a horizontal there. We can find this dimension, the difference between the 143.30 and the 97.50. That's going to be 45.80. Should be 45. 143.30 minus 97.50. What else can we find there? That seems to be all we can find at the moment, so let's go with that. Let's see what we can do with that. With that information, we could find a triangle like this. Oops. So I can draw my sides straight. That would be a right triangle. And I could find angles off of that. So off of that right triangle, let's go ahead and solve that right triangle, see what we come up with. Sometimes it's not a matter of what you're looking for, sometimes it's a matter of what you have. And this is all we have here. So off of this triangle, I'm going to find my angles. I'll find this angle, and I'll find my missing side. Let's do the missing side first. How am I going to find that? Perfect. A squared plus b squared equals c squared. So it's the square root of... you could, it's just more precise if you just use the... Tangent is going to give us our angle here in just a second. But it's more precise if you go off of the a squared plus b squared equals c squared. You're not looking at rounded dimensions then. So 77.889 it looks like. Since we're going to two decimal places, we're going to call this 77.89. Our angle up here, I'm going to go for the one in green here first. Again, I'm going to use the information that we found directly, not rounded information. This is rounded, so I'm not going to use that in this calculation if I can avoid it. So I'm looking at a tangent is opposite over adjacent. I am looking for the angle. Which side's the opposite side here? I'm looking for this angle. 4580. And then the 63 would be the adjacent. So when I am looking for an angle, I use an inverse trig function. This is tangent, so I use inverse tangent to cancel that out. So I have to use an inverse tangent over here. So my angle is equal to the inverse tangent of 4580 divided by 63. Which gives us 36.02 degrees. If that is 36.02 degrees, that makes this down here 53.98 degrees. Well, how does that help us? Well, we come back up here. Now I have this right triangle. I know this side off of that other one, and I know this is the radius. This is going to be 4380 right here. So let's draw that triangle and look at it in more detail. This is the radius of our circle, 4380. This here is just this side right here, so that's the 7789. So now with that information, I can solve this triangle. I could find this dimension here. This would actually be c squared minus b squared equals a squared. So let's do it, 77.89. Minus 4380. 64.41 that comes out to be. And we can find our angles here. Let's find this angle over here first. Again, I'm going to go to the angles. 4380 is a given angle. That's exact. Both of these are rounded. But this one is closer to being a given measurement because I calculated this one from that one. So this one's been rounded twice. This one's only been rounded once. Do you understand what I'm saying? I rounded this one in its calculation, but then I used that rounded number in the calculation of the next number. So I always want to go as far back as I can, as close to the original data as I can. It just keeps us from having stacked up round off errors. It's called tolerance buildups. So I have, if I'm finding this angle, this is my hypotenuse. This is my opposite side, which is what trig function? Sine. So sine of our angle is going to be the opposite of 4380 over the hypotenuse is 7789. And when we are looking for an angle, we use that inverse trig function. It's a sine, so we're going to use an inverse sine. So our angle is going to be the inverse sine of 4380 over 7789. .22 degrees. Now we have enough information to find y. Because if I look back up here, here's y. Y is just a combination of those two angles. This angle right here we found to be 36.02. This angle right here we just found to be 34.22. I add those together to get y, which is going to be 70.24 degrees. Or 70 degrees, 40 minutes. Not 40 minutes, 70 degrees. What is that? Not even close. 7 degrees, 14.4 minutes.
And that other triangle there, you put this angle as well, add up to 90
Yeah. Notice that first triangle I drew in, we didn't end up using. And that's kind of the nature of the beast in these. Sometimes you find information you're not going to use, but it's a matter of just look at what information you can find from what you're given, and then try to use that to get somewhere close to, somewhere in the vicinity of what you need. Here, I honestly thought I was going to be able to find this angle and do a complement. We'll subtract from 90. I wasn't able to. In the process, I ended up finding two angles that added up to the one I was looking for. That's the tough part about these problems. You may take off in a direction and realize you can't get there, so you got to back up and go a different direction. Pencils are good, or just a lot of scrap paper. Most of the drawings in this packet aren't big enough that you can really do the work on them anyway. Okay, I want to pick another one to do. Let's do one like number 10. This is on page 369, number 10. I am asked to find this angle here, given this diameter is 0.9846, and this diameter here is 2.3850. And this angle up here is given at 4840. So to find angle y, let's look at what we know again. Well, finding right triangles here is going to be just simply radius to a tangent. So I have one right triangle there. I chose this side because it's closer to the side I'm moving to. I'm moving over to this one here. There's going to be a right triangle here as well. The right angle is actually going to be right there. And they're going to share, those two right triangles are going to share this side here. That tangent has to be the same length for both of them, because the circles are tangent to that same line at the same point. So I'm going to start out with this triangle right here. I'm going to redraw it. This is my right angle. What I know here is I know this angle here is half of this angle. That's 4840, so this one's going to be 2420. That's a big one always. You've seen that one twice today already. When you go from the center of a circle to the intersection of the tangents, it cuts that angle between the tangents in half. And then this is going to be half of our diameter, which is going to be 1.1925. So I want to find the length of this side here. So that is going to be opposite and adjacent. So we're going to be using a tangent. So let's fill in what we know. We know that the angle is 2420. You know the opposite side is 1.1925. And we are looking for the adjacent side. 1 times 1.1925 is 1.1925 divided by the tangent of 2420. Which gives us that adjacent side is 2.637. This is 2.637, which makes this here 2.637. So now let's look at this triangle over here. This is the 2.637 that we just found from the last triangle. This is going to be the radius of that circle, so half of the 0.9846, that's 0.4923. And if I find this angle up here, I know that this angle is just double that. Y is double of that. So let's find that angle there. So according to that angle, this is the opposite and this is the adjacent. So we're looking at tangent again. So the opposite side is the 0.4923. Adjacent is 2.637. And again, since we're looking for the angle, it's an inverse trig. That's a tangent, so we're using an inverse tangent. So theta is equal to the inverse tangent of the 0.4923 divided by 2.637 gives us an angle of 10.575 degrees. We know that y is double that because what we found was this angle. Takes two of them to make y. So I'm going to multiply that by 2. I'm going to keep it in my calculator without clearing it. And I'm just going to multiply that by 2 so I don't get a second round off error. So 21.149. And here's what I'm going to do is I'm going to convert that. You guys have the convert to DMS function right on your calculator. I'm going to do it manually here. So I'm going to subtract the 21 degrees. Take that decimal then times 60 to turn it into minutes. 8.97, so we're just going to call that 21 degrees and 9 minutes. What do you think?
I have a question.
Yes.
How do you know, like, this is for the other problem, but
Yep.
it was tangent, whatever. Say you have tangent 36.33, right?
Yep.
Equals 1.1 over. Then you're looking for that number.
Okay.
How do you know when you have to take 1.1 divided by tangent 36.33?
Okay.
Why can't you take tangent 36.33 divided by 1?
Good
How
question.
do you know when to do that?
Good question. So let's say your tangent 36.1 degree here equals 33.5 over the adjacent side. Remember we talked about proportions, cross multiply and divide? Whenever you're looking for a side, the easiest way to solve these is to make it a proportion. So you put this trig function over 1, then you cross multiply. So here's my missing number. So this is the diagonal. So I multiply the 1 times 33.5, and I divide by the tangent. If the missing number were on top, let's say this was 42.7 or whatever. So now I gotta put this over 1. Here's my diagonal. I multiply those and divide by 1. Or just multiplying. Then of course the third case is if I was looking for the angle. Then if I'm looking for the angle, then it's an inverse trig. So it's a tangent, so I do an inverse tangent. That's a good question, though. That's the biggest thing people do wrong is they want to look at it. So do I multiply or divide? Set up the proportion, then the diagonal tells you which one's to multiply, and the leftover one is what you divide by. Okay, I want to give you guys some time to work on these. So in that packet, page 368 through 70 or 71? 371. There is 1 through 23, the odds. We will probably do a couple more examples of these tomorrow. Because this is the important part of the course, is finding these missing pieces. And this is what the trig is all about. And the hard part of the trig, like I said, is finding those triangles. You saw in that one example, I started out one direction, ended up solving it in a totally different direction. Okay, I'll let you guys have your last 14 minutes to get started on those.